Hi, I'm Paul, and we're the Oceanic Oscillator, here to demonstrate our engineering design process. Here are the oscillators today, ready to make waves in the energy industry. To achieve the carbon neutral goal by 2050, New South Wales Government has an interest in using renewable energy to power public infrastructure. UNSW engineering students have been contacted by New South Wales Government to design a scaled model of an oscillating water column that can power the Sydney's North Head sewage treatment plant through wave energy. I want to first address the importance of problem definition, which is the beginning for every engineering project. There are a few benefits the problem definition process provides. Problem definition ensures the problem is well understood by all parties involved. This common understanding helps reduce confusion and miscommunication. The problem statement produced in this phase will set the direction for the entire project and ensure all efforts are focused on the key points. In addition, the problem definition improves decision-making throughout the engineering design process. Engineers identify the context, objectives, functions, and constraints of the project during the problem definition phase. This allows the team to generate relevant conceptual designs, define success, set relevant metrics for testing and for verification of prototypes. The scope, context, objectives, functions, and constraints identified in the problem definition allows the engineering team to identify tasks required to complete the project and estimate the time required. This helps project management through the entire engineering design process and ensure the team is on track to finish within the given time frame. Lastly, the cost of each design increase because as the engineering design process progresses, the time, money, energy invested increases as well. By concisely defining the project, engineers could avoid misunderstanding the clients and producing products that fail to meet requirements of the client, thus saving time and resource. An example of failed problem definition would be the Health.gov website in the US. It's supposed to help Americans choose private health insurance, but went down on day one due to technological issue. The investigation later found out the software engineering team was not aware of the scale of the operation and therefore did not prepare the server to handle everyone in the US to use this website at the same time. In conclusion, without a clear problem definition, there is a risk of confusion between team members and the client, wasted time and resource, and an ineffective solution. Therefore, it is essential to invest time and effort in the problem definition phase.
Hi, good afternoon. I'm Shua, and today I'm going to be introducing you to the first steps we have taken in creating our own problem statement. And by using a objective tree diagram, we were able to define and identify the various different objectives, constraints, and functions which ultimately form the roots of our problem statement, our formal problem statement, which will be shown in the next slide. This ultimately increases its quality, and for the engineer, this makes it clearer on what exactly he needs to build and design. By definition, objectives is what the device actually needs to look like, the functions is the things it might need to perform, and the constraints is various limitations on the actual device. The aim of this is to minimize any doubts that the engineer might have after reading the problem statement, and some examples of this, of where we formed paragraphs around the roots through objectives, constraints, and functions, will be displayed on the next slide by my team partner, and he will point out exactly how these objectives, functions, and constraints served as fundamentals in writing the formal problem statement.
For our problem statement, we took a look at the wave energy project brief and worked out what the main objectives and constraints from there. The ones highlighted in blue are the who's, being the UNSW engineering students, and the clients, the Sydney North Head sewage treatment plant. So firstly, we noted the main objectives, which was to fill up the balloon to maximum capacity within 3 minutes. But how will the OWC be able to do so? We noted out that, aside from the need for it to be aesthetically pleasing, the oscillating water column should also be able to withstand the force from the waves, meaning that its structure will stay in place for the duration of the time. The OWC must also be waterproof for the duration of the testing time, or else the OWC may not be able to fill up the balloon as the materials may give up on the structure. Moving on to the constraints, the device must fit inside the wave loom of specified dimensions while being portable. Without doing so, the OWC will not be able to fill the balloon at its best rate, as air may escape, or worse, the OWC may be destroyed. This is related to the fact that the OWC must be portable, where the dimensions may not match with a wave plume and hence easily pushed out by the wave. Another constraint is that the one-way valve needs to only allow air to pass through, as water that enters there may hinder the rate at which the balloon is filled up. Lastly, there is a time constraint on the project wherein the OWC must be completed by week 10. Moving on to concept generation, I will pass the floor to Max.
Hi, I'm Max, and I'll be taking you through the importance of concept generation as well as discussing some of our own. Concept generation is a crucial part of the design process that allows designers to explore many ideas and possibilities. Promoting creativity and innovation, the conceptual design phase enables designers to plan and sketch increasingly improved solutions. Generating multiple concepts allows designers to identify potential problems and their solutions before finalizing the design. This reduces the potential risk of mistakes and design flaws throughout the construction phase. The conceptual design phase also helps streamline the design process by bringing every idea together, making it easier to identify the best solution for the final design. Having multiple designs allows designers to communicate their ideas with clients and stakeholders, reducing any ambiguity. By evaluating the design concepts against objectives, functions and constraints, the final design is ensured to be of high quality and aesthetically pleasing. Examples of our own annotated concept generations can be seen on the left. Annotations are important as they provide insight into what the designer was thinking at the time, reducing confusion when looking back. The top left design features a relatively large base structure to increase the air pressure within the wave column. The solution below this includes a larger opening and column, as well as the output being placed at the top rather than on the side. The final design features a curved wall to allow water to push air out more easily, with the ceiling being tiered to break waves, increasing the structure of the device.
Above me is a demonstration of how we use the morph chart, which is one of the various tools used in the concept generation phase. This was particularly useful in our engineering design process, since the column on the left displays either objectives, functions, or constraints, which we were able to illustrate various possible solutions to that specific issue listed through the multiple rough sketches alongside the defined problem. They particularly help us in brainstorming as many possible ideas, no matter how unrealistic, since this graph acts as a visual reference for what our features might end up actually looking like. As you can see from the first line as an example, the issue addressed was how the top of the column might look like, considering the constraint is that it must contain a compartment in which the PVC or one-way valve will be implemented. Through these three quick sketches on the right, we now have a more accurate idea on how to address this issue, and as shown in our final sketch on the furthest to the right, for that issue, we opted with going for the pyramid-shaped roof, which not only contains the compartment, but also directs airflow into the balloon, perhaps quicker, we might not know yet, which also addresses the objective of having the highest peak of airflow possible. And so on, we repeated ourselves for different problems and provided multiple sketches.
Hi, I'm Prithviraj. So, this is a model sketch of an oscillatory water column with a detailed annotation which acts as a tool to our concept generation. We are going to install a wooden plank to the water column so that the waves will enter the air chamber and the air present in the waves will pass through the PVC pipe and ultimately inflate the balloon. So, this was a presentation about the prototype of the oscillatory water column. So the next steps that we will take is to test various features of a model that are evident in our concept generation to see which design works best and is most functional so we can implement that in a final design. We hope that you liked our presentation. Thank you.